Hi everybody, and welcome to Lesson 2.6, Types and Uses of Energy. The content in this video is aligned to the third edition of Environmental Science for AP and covers information from College Board Units 6.1, 6.2, 6.3, and 6.4. We've discussed population and its growth, as well as the way we use land. In this unit, we will discuss the way in which these growth patterns and ways of life are powered. This leads us to the content objective of understanding that humans use energy from a variety of sources, resulting in positive and negative consequences. By the end of this lesson, you should be able to identify differences between non-renewable and renewable sources, describe trends in energy consumption, identify where natural energy resources occur, and identify types of fuels and their uses. Which leads us to being able to answer the guiding question: why do we use the energy resources that we do? To understand energy use, we first have to understand the kinds of energy that are available to us. Energy resources are classified into two large categories: non-renewable and renewable. Non-renewable resources are those whose sources are finite. This means that they will eventually run out. These resources are often made of the remnants of long-dead organisms, such as the ancient bogs, forests, and dinosaurs that provided the organic material for coal, oil, and natural gas. There is also a component of non-renewable resources that is not carbon-based. This is nuclear fuel. Nuclear materials, most often uranium, are made of radioactive elements that are also found in finite amounts. Renewable resources can be specified even further. By definition, a renewable energy source is energy source that can replenish itself, typically over the span of a normal human generation. While most people would refer to solar energy as a renewable resource, that is using the general or non-scientific definition of renewable. Resources such as solar, geothermal, wind, and flowing water are more specifically defined as being perpetual. This is because they are managed by the laws of physics of the universe. This means they are constantly existing and constantly occurring. For the foreseeable future of the human race, the sun will continue to burn, the mantle of the earth will continue to churn, temperature differences will force the movement of air, and gravity will continue to pull water downward. Perpetual resources are a subclass of renewable resources. In the large scheme of things, you wouldn't be wrong if you called a solar energy resource a renewable resource. Here we see a global map that points out the most abundant locations of the non-renewable resources found on Earth. It's important to take a moment here and identify why the renewable energy locations are not identified on this map. This is because, with very few exceptions, renewable energies can be found or installed just about anywhere. The question arises to their efficiency and effectiveness in those areas, but the fact remains that they can be placed there. Now, let's return to the map here. You see that there are four non-renewable categories defined: natural gas, petroleum, coal, and uranium. Coal is one of the oldest forms of non-renewable resources that humans have used. From the time it was discovered and found to be combustible, we have used it for heating, cooking, and electricity generation. Today, the largest known reserves, or deposits of a resource that are economically viable to extract, are found in the United States and Russia, with China and Australia just behind. In the U.S., the majority of coal is found in the Appalachian Mountain area, particularly in Virginia, West Virginia, Kentucky, Tennessee, and parts of Ohio. Petroleum is found in economically viable levels almost exclusively in the Middle East, particularly countries belonging to OPEC, or the oil-producing and exporting countries. There are some deposits of petroleum in Texas and Alaska, but they are not as economically viable as those found in the Middle East. Natural gas often co-occurs with petroleum deposits, but it can be found on its own. For this reason, it should be no surprise that there are also large deposits of natural gas in the Middle East. We also have it occurring in the northern parts of Russia. Lastly, we have uranium, which is the primary fuel for nuclear power. The largest reserves of uranium can be found in Australia, particularly in the areas of the outback that are not heavily populated. Remember, kids, in Australia, not only do the plants and animals want to kill you, but the rocks do too. Remember that renewable energy sources can theoretically be installed just about anywhere. There are a few exceptions, those being biomass and geothermal, that require more specific conditions to be economically useful. In these cases, biomass requires arable soil and sufficient water to be able to produce the organic material used for burning or other conversions. Geothermal energy is only functional in areas with relatively abundant tectonic activity, such as near volcanoes or natural hot springs. The graph shown here is an amalgamation of all the renewable energy resources being used in a particular country. You'll notice that the top three are China, the United States, and Germany. China has one of the largest hydroelectric power plants in the world, the Three Gorges Dam. Much of this value, which is measured in gigawatts per year, comes from that hydroelectric plant. The United States also uses hydroelectric power plants, but we are also introducing larger amounts of wind and solar farms to increase our renewable production. Germany comes almost exclusively from wind energy. This graph shows us the relative increase in the amount of energy resources being used over the course of the period from 1820, right after the start of the Industrial Revolution in the US, up to the year 2000. In the past 20 years, these trends have not only continued to sharpen the divide between renewables and non-renewables. The graph shows as a whole the exajoules per year of energy consumption. 1 exajoule is equal to 1 times 10 to the 18th power watts. As you can see, prior to the 1840s, energy consumption was almost exclusively in biofuels, here also referring to biomass. Upon the discovery that coal was a useful energy resource, it began to shift away from complete reliance on biomass. This trend continued, with coal consumption steadily increasing until the development of extraction and refining methods for petroleum in the early 1900s. Petroleum quickly became a staple in energy generation, particularly as automobiles became more common and we began to develop plastics. Natural gas came at about the same time, as it is often known to co-occur with petroleum deposits. Hydrologic and nuclear power were added to the resource collection last. It is no surprise that the two of these began at approximately the same time. Nuclear energy was a byproduct of the experiments in the Manhattan Project in the 1940s that produced the first atomic bombs. One of the components of these is something called heavy water, which is only produced by putting high voltage current through water. This is a byproduct of using water as an energy generation process. After issues like 3 Mile Island and Chernobyl in 1979 and 1986, nuclear power fell out of favor in the United States. However, it is currently being discussed as an option as a transitional energy resource as we plan the move from non-renewable to renewable resources. Here is a current view on the way we use energy resources on a global scale. One thing to note is that the vast majority, over 75% of our energy resource use comes from non-renewables. This is largely because they are easier to access and have a very high EROEI, or energy return on energy investment. Fossil fuels like oil, coal, and natural gas are easy to extract, refine, and transport, making them economically viable, and provide large amounts of energy for each component used. Biomass has increased in usage over the past 5 to 10 years as a focus on biofuel and ethanol-based gasoline replacements have come into favor. This can be traced back, in part, to the push toward hybrid and electric cars. Additionally, a growing environmental movement engaged in large-scale public campaigns to raise awareness of the benefits of biomass and other renewable energy. Overall, approximately 15% of global energy consumption comes from renewable energy resources, such as geothermal, solar, wind, and hydroelectricity. The remaining value comes from nuclear generation. It is interesting to note that as of 2022, both Iceland and Costa Rica have converted their energy grid to 100% sustainable resources. Several cities in the U.S. have followed suit. Finally, let's take a look at the comparison of fuel types and their uses. Overall, you may see that it becomes repetitive as the vast majority of them are used as a resource to produce electricity. The table here looks at a variety of non-renewable resources and compares them across location and use. Petroleum and crude oil are terms that are used interchangeably. Petroleum can be refined through the process of distillation into a variety of liquid fuel resources with different properties and uses. The majority of petroleum is used for transportation and the production of plastics. Small amounts of it are used as a source for electricity generation. Coal, however, found most abundantly in the US and Russia, comes in three forms of varying quality: peat, bituminous, and anthracite. Coal is currently used in developed countries almost exclusively for electricity generation. Natural gas, co-occurring with many petroleum deposits, occurs in Russia, the Middle East, and parts of the US. Common examples are methane, butane, and propane. This too is used for electricity generation. Tar sands and oil shale are both very dispersed, very low quality resources that require extensive refining to make them usable. Tar sands are found mostly in Canada and Venezuela, where oil shale is found primarily in the United States. Both resources come from small amounts of bitumen, a component of coal that is found in sand or sedimentary rock. Because of their dispersed nature, these resources are not useful for electricity generation. Instead, they are often used as raw materials for the production of petroleum-based products. Lastly, we have uranium, which is found in its highest natural abundance in the Australian outback. Naturally occurring isotopes include uranium-235, which is the most common component used in nuclear power, and uranium-238. Uranium is used exclusively in civilian purposes for electricity generation. Lastly, we have the renewable energy sources. One of the things we cannot do here with much certainty is say exactly where these resources will always be found. With the exception of geothermal and biomass, they could occur in varying degrees of success in many places on the planet. However, this chart, when possible, has identified the best criteria for finding these resources. Biomass, plant and animal matter, is found anywhere that arable soil is able to support populations of plants and animals. These resources are used in large quantities for birding to heat homes and cook food, particularly in lesser developed countries. Wheat and corn are also used to go through the fermentation process, which produces ethanol as a basis for other biofuels. Solar energy requires areas of undisrupted direct sunlight. For this reason, areas close to the equator that lack tree cover are the best for getting maximum energy production. Areas such as the Middle East and Egypt would provide good locations for these components as energy resources. Solar energy can also be used passively to do things like provide natural heat and light within a home or office. Wind energy requires solar input, as we know that wind is formed from temperature differentials and air masses moving from areas of high heat to low heat. Wind turbines are most effective in flat areas with little to no obstruction. Plains and coastal areas are highly effective with this resource. Wind energy is primarily used for electricity production. Hydrologic power requires strong flowing water. For this reason, large, swift-flowing rivers provide the best opportunity for hydroelectric energy generation. Should that river have an area of steep drop-off, hydroelectric energy generation can increase substantially. Areas such as the Three Gorges Dam in China and the Hoover Dam in the U.S. are used exclusively for electricity generation. Lastly, we have geothermal energy. This is one of the renewables that requires a very specific set of conditions. It only occurs in areas with geologic or tectonic activity. Areas near Yellowstone in the U.S. or in Iceland are abundant locations of geothermal energy because of their exceedingly active mantle. Geothermal energy can be used to heat water for cooking and bathing, but can also be used to heat homes through things like radiant floors. The following slide provides you with an opportunity to see how some of these ideas are connected together. Feel free to pause the video and explore the connections between these topics. Then, use the statements at the beginning to review.